Hi everyone! Today we're going to be talking about angle relationships. Our objectives for today are that students will be able to identify and use special angle pairs, and you'll be able to identify perpendicular lines. Let's get started. Why do we need to learn about angle relationships? Here's a real-world example. Cheerleaders position their arms and legs at specific angles to create various formations when performing at games and at competitions. Certain pairs of angles have special names and share specific relationships. So here's one real-world example of when you will see angle relationships and special angle pairs. All right, in your notes you have a handy dandy little graphic organizer talking about that describes the different angle relationships, and we're going to go through each one together. All right, the first type of angle pairs that we're going to talk about are vertical angles. So vertical angles are when two angles are across from each other on intersecting lines, and they are always congruent. So an example of what this looks like is if we had two lines that looked like this. All right, vertical angles would be this angle and this angle. These would be vertical, and those would be congruent, all right? They're across from each other. So this angle is across from this angle. They're like across the street neighbors, all right? They're across from each other, and they are congruent. These angles would also be congruent. So we've got this one and this one. The green angles are also congruent to each other. So if we call these angles 1, 2, 3, and 4, statements we would write is we would say that angle 1 is congruent to angle 3 because they're vertical angles, and angle 2 is congruent to angle 4 because they're vertical angles. Alright, so here's some real-world examples of when you'll see vertical angles. So in a railroad crossing sign, right, you've got an X, these are vertical angles, and these are vertical angles. In a helicopter, the wings or the propellers, I don't know exactly what they're called, alright, the things that go in circles and circles and get the helicopters off the ground, alright, if somebody knows what they're called, tell me, let me know, alright. These are vertical angles, and these are vertical angles. And then in scissors, all right, we use scissors every day. There's vertical angles right there, and then these are vertical angles because they're across from each other. All right, the second type of angle relationship we're going to talk about are adjacent angles. So adjacent angles are when we have two angles that are next to each other and share a common side. So for example, if we had two angles that looked like this, all right, if we had a diagram that looked like this and they share this common side, all right, let's call this angle 1 and angle 2. All right, these two angles would be adjacent to each other. Angle 1 and angle 2 would be adjacent to each other because they share this common side right here. All right, here's a couple real-world examples of when you'll see adjacent angles. So in an orange, all of the pieces of the orange, these are all adjacent angles to each other. All right. In a bridge or a roof when you're building, all right, construction workers and engineers use adjacent angles all the time. Next, we have complementary angles. So complementary angles are any two angles whose sum is 90 degrees. So when we add up the measures of those two angles, it equals 90 degrees. Here's an example of complementary angles. So if we had a diagram that looked like this, we've got an angle, and we know it's a right angle because of that little square. All right, if it looks something like this, we have angle 1 and angle 2. All right, this would be angle 1, and this would be angle 2, right? If we add them together, we know it equals 90 degrees because of this little square right here. All right, angle 1 and angle 2 are complementary angles. And how we would express this using symbols and notation is we would say that angle 1 plus angle 2 equals 90 degrees. And therefore they are complementary angles. All right, so I thought this was kind of funny here. All right, we've got two angles that are complementary to each other, all right? And two angles that are complementary to each other both have to be acute because they have to both add up to 90 degrees, so they have to each be less than 90. They have to be acute angles. So you've got one complementary angle giving a complement to the other complementary angle, saying, your acute angle. No, your acute angle, all right? So that's one way you can remember that complementary angles are acute angles. They have to both be acute, all right? And then here's another real-world example of when you would see complementary angles. A baseball diamond, all right? Baseball diamond, this forms a 90-degree angle right here, all right? And if you were to go down the pitcher's mound through second base into outfield, draw a line down the middle, this would be complementary to this angle. All right, now supplementary angles. Supplementary angles are any two angles whose sum is 180 degrees. So an example of supplementary angles would be if we had something that looked like this. All right, and we said that this was 135 degrees and this was 45 degrees. All right, if we take this angle plus this angle, it equals 180 degrees. Therefore, these two angles are supplementary. All right, this bridge right here is a real-world example of supplementary angles. So the angle in this truss bridge right here plus the angle of this part of the truss bridge adds up to 180 degrees. Therefore, they are supplementary angles. All right, it's very important that you know the difference between supplementary and complementary. We're going to be using this all year long, so I highly, highly, highly recommend that you try to memorize it right now. A little trick to remembering which one's supplementary and which one's complementary, all right, supplementary angles add up to 180, and there's an 8 in 180, all right? An 8 kind of looks like an S, right? We've got an S for supplementary, and if we've got our S for supplementary and we just kind of connect it, it makes an 8, all right? So it's just kind of a little trick to help you try to remember which one is 180 and which one's 90, all right? And then if you did a C for complementary, here, let me use a different color so we can see this better. A C for complementary, if you draw a line down it, now it's a 9, and complementary angles add up to 90 degrees, all right? Supplementary, S for supplementary, connect it, make it an 8, and it's 180 for supplementary, all right? Whatever helps you remember that 180 degrees is supplementary, 90 degrees is complementary, all right? But you need to memorize those. And last but not least, we've got a linear pair. So a linear pair is two angles that are both adjacent and supplementary. They always form a straight line. All right, so for example, if we had something that looked like this, all right, very similar to what I showed you in supplementary angles. However, if we're just talking about supplementary angles, they don't necessarily have to look like this, all right? But a linear pair, we've got angle 1 and angle 2. They have to be both adjacent, so they have to share a side, and they have to add up to 180 degrees, all right? So they have to be supplementary and form a straight line, all right? Therefore, angles 1 and angle 2 are a linear pair, and angle 1 plus angle 2 equals 180 degrees. All right, the key difference between, let's see, a linear pair is always supplementary, but a supplementary pair of angles is not always a linear pair. All right, that's the important thing to remember. All right, here's an example of a linear pair on a soccer field. All right, so these lines right here form a linear pair. We've got horizontal line, vertical line right down the middle. These would actually be perpendicular, right? They form 90-degree angles, all right? But they're a linear pair because 90 plus 90 equals 180, all right? They form a straight line and they share a common side. All right, now we're going to go through these and check off all the relationships between angle 1 and angle 2, all right? So number 1, these are not adjacent angles because they do not share a common side. All right, angle 1 is this angle, angle 2 is this angle. They do not share a common side. They are vertical angles. They're across the street from each other. They're across from each other, all right? We don't know if they're complementary because we don't know what their measure is. We don't know if they add up to 90. We don't know if they're supplementary. If we don't know if they're supplementary, we can't say they're a linear pair. So therefore, we would just classify these as vertical angles. All right, number 2, we've got angle 1 is right here and angle 2 is right here. They do share this common side, so they are adjacent to each other. They're not vertical because they're not across from each other. They are complementary because we know they have to add up to 90 degrees. If this one right here is 90 degrees, that means this also must be 90 degrees because it's a straight line. All right, so angle 1 plus angle 2 equals 90 degrees. It equals a right angle, so they are complementary. All right, we know that they equal 90 degrees. They don't equal 180, so they're not supplementary. And they're not supplementary, so they cannot be a linear pair. All right, number 3, we've got angle 1 right here and angle 2 right here. So they are adjacent because they share this common side right here. So we can check that box. They're not vertical because they're not across from each other. They're not complementary because we know if we add them together, it's more than 90 degrees, all right? They form a straight line when we add them together, so we know that they're supplementary, all right? They add up to 180. And if we can check off the adjacent box and the supplementary box, that means that they are a linear pair because a linear pair has to be both adjacent and supplementary. All right, number 4. We know that angles 1 and 2 share a common side, so we can say that they're adjacent. They're not vertical because they're not across from each other, and we don't know what their measures are, so we cannot say if they're complementary, supplementary, or a linear pair. So therefore, number 4, all we can say about them is that they're adjacent. All right, number 5. Number 5 is a little tricky, so what I want to do is go through this first with you before we check off any boxes. We want to identify what are the angle measures of all these. All right, these little symbols right here mean that this angle is congruent to this angle. All right, the little tick mark and the little tick mark means that this one is congruent to this one. We also know that there's a right angle here. That means this is also a right angle, that it equals 90 degrees. All right, if this whole thing equals 90 degrees, so this angle plus this angle equals 90 degrees, and we know that they're congruent, all right, we can cut the 90 in half. Therefore, each angle equals 45. So this equals 45 degrees, and this equals 45 degrees. All right, now we also know that this angle, we know that angle 1 and angle 2 are vertical angles. All right, so we can check off the vertical angle box, all right? But that also means that angle 2 is congruent, all right? It is also congruent to angle 1, so it is also 45 degrees. All right, now we want to continue going through. They're not adjacent, so we can't check off adjacent, all right, because they do not share a common side. Remember, we're looking at angle 1 and angle 2 here. We know they're vertical. We also know that they're complementary because if we add them together, 45 plus 45 equals 90, so they are complementary. If they're complementary, they're not supplementary, and if they're not supplementary, they're not a linear pair. Therefore, these are vertical and complementary angles. All right, why don't you try to do number 6 on your own? Check off the boxes, check off all the relationships between angle 1 and angle 2 in this example. When you come back, I'll have the answer written on your screen, and I'll quickly go through it with you. All right, so go ahead and pause your video now. All right, number 6, you should have gotten that they are vertical and supplementary. All right, first thing, we automatically know that they're vertical because they're across from each other. All right, they're not adjacent because they don't share a common side. Now, we know that this right here is 90 degrees. Therefore, they're perpendicular, and they all form 90 degrees. So this is 90, this is 90, this is 90, and this is 90. Therefore, angle 1 plus angle 2, 90 plus 90 equals 180. Therefore, angle 1 and 2 are supplementary. All right, this is an example of two angles that are supplementary, but they are not a linear pair. All right, they're not a linear pair because they're not adjacent. If they're not adjacent, they're not a linear pair. All right, and that's the difference between supplementary and linear pair. All right, now we can use angle relationships to find angle measures, and sometimes it involves a little algebra. Sometimes it just involves some simple addition or subtraction, but we have to know our angle relationships in order to find the missing measures. All right, so with example number 1, these two angles, we're dealing with this angle right here and this angle right here. We need to find angle x. What is the relationship between angle x and the 112? If you said that they are vertical angles, you are correct. They're vertical angles. And we know that vertical angles are congruent. So if this angle right here is 112, this angle is also 112. Therefore, x equals 112, all right, because they are vertical angles. All right, number 2, if we're looking at this diagram, we see that this is a right angle right here. Therefore, these two angles are complementary angles, all right? We know complementary angles equal 90 degrees. Therefore, x plus 68 has to equal 90. Okay, if we add them together, it equals 90. So subtract 68 from both sides, and x equals 22. And you're done. All right, number 3, they form a straight line, all right, and they share a common side. They're adjacent, so they are a linear pair, these two angles. All right, we know linear pair are supplementary. Therefore, when we add them together, it equals 180 degrees. Therefore, we know that 124 plus x equals 180. So subtract 124 from both sides, cancels out, x equals 56. All right, we're going to skip number 4. We're going to move on to number 5. Number 5, we're looking for x, y, and z, and we've got to know and use all of our angle relationships. So right off the bat, we're going to do the one that looks easiest and use our angle relationships to find y, all right? So we know if this one is 72, y is a vertical angle. Therefore, y equals 72 degrees as well, all right? So this one right here is 72 degrees. Then we also know that if this is a right angle, that means this is a right angle as well. So these are complementary angles. So 72 plus z equals 90 degrees. Subtract 72 from both sides, and we get that z equals 18. Right? So this one right here equals 18. And then last but not least, if we want to find x, all right, we know that x plus y equals 180 degrees because angle x and angle y are a linear pair. They share this common side and they form a straight line, so they add up to 180 degrees. So we know that x plus y equals 180 degrees. We know that y equals 72, so we can substitute in 72. Then we want to subtract 72 from both sides, and that solves for x. So x equals 108. So angle x is 108 degrees. All right, so you have to know and use all of your angle relationships in order to solve for these missing measures. If you don't know your angle relationships, this can be a little challenging. If you know your angle relationships, it should be a breeze. All right, number 7, all right, we've got some problems that look like word problems, but do not be intimidated by them, all right? Let's read through number 7 together. We know that angle A and angle B are complementary angles. Right off the bat, we know that complementary angles, when we add them together, it equals 90 degrees. If the measure of angle A is 42 degrees, find the measure of angle B. All right, so we know that the sum of complementary angles is 90 degrees. So we know that the measure of angle A plus the measure of angle B equals 90 degrees. Now we know that angle A, the measure of angle A, is 42 degrees, so we can substitute that in for the measure of angle A. Then we can just solve for the measure of angle B like an algebraic equation. Subtract 42 from both sides. These will cancel out. The measure of angle B equals 48 degrees. And you're done. All right, so read through the problem carefully, identify what angle relationship you're using, and set up an equation to solve. All right, number 9. Angle 1 and angle 2 form a linear pair. before we go any further, we know that a linear pair, the sum of a linear pair is 180 degrees because a linear pair is supplementary, meaning that when we add together the angles, it equals 180 degrees. If the measure of angle 1 is 113, find the measure of angle 2. So we set up an equation to represent this linear pair. The measure of angle 1 plus the measure of angle 2 equals 180 degrees. We know that the measure of angle 1 is 113, so we substitute that in for the measure of angle 1. Then we're just going to solve for the measure of angle 2. Subtract 113 from both sides. Cancel out over here. And the measure of angle 2 equals 67 degrees. Alright, now for these next few problems, we're going to be using a little bit more algebra, right? We're throwing some expressions, more equations in there, alright? So, we read through the problem carefully, label our diagram, write an equation, and solve for the variable, or solve for whatever the problem's asking us to find. Alright, so right off the bat, if line AB is perpendicular to ray CD, we know if it's perpendicular, that means that these are both 90-degree angles, okay? If the measure of angle C, or DCE, which is this angle right here, equals 7x plus 2, and the measure of ECB, which is this angle right here, equals x plus 8. Find the measure of angle DCE. So first we need to find x, and then we can go back and plug it in to the measure of angle DCE, or 7x plus 2. So first things first, we know that this angle is going to be 90 degrees. So 7x plus 2 plus x plus 8, if we add those two angles together, it equals 90 degrees. Now we can solve for x, combine like terms. So the x's with the x's, we get 8x, the numbers with the numbers, plus 10. Subtract 10. 8x equals 80. Alright, then if we divide by 8, x equals 10. Alright, so we solved for x. But the problem's asking us to find the measure of CDE. Oops. Alright, so we want to find that measure, so we take our x and plug it back in to 7x plus 2. So we know that 7 times x, which we know is 10, plus 2 is going to equal the measure of DCE. Alright, so 70 plus 2, the measure of angle DCE equals 72 degrees. And that is our final answer. Always make sure you're solving for whatever the problem's asking you to find. Alright, number 13. Number 13 is asking us to find the values of x and y. We know that the measure of DEG, which is this angle right here, is equal to 5x minus 4. We know that the measure of GEF, which is this angle right here, equals 7x minus 8. And then we know that the measure of DEH, which is this angle right here, equals 9y plus 5. So first things first, we want to use our x's together, okay? We want to group our x's together. So we want to look at what is the relationship between this one and this one, which would be this angle and this angle. All right, the yellow and the green angle are a linear pair, meaning that they're adjacent because they share this common side, and they add up to 180. They are supplementary. So we can say that this angle plus this angle equals 180. Therefore, this plus this equals 180. And that's our first equation. So 5x minus 4 plus 7x minus 8 equals 180. Combine like terms, so the x's with the x's, and we have got 12x. The numbers with the numbers, minus 12 equals 180. Add 12. 12x equals 192. Divide both sides by 12. Plug that into our calculator, and we get that x equals 16. All right, so we just found the value of x. Now, if x equals 16, what we can do is we can plug that back in and find the measure of angle DEG. All right, so if x equals 16, we would say 5 times 16 minus 4. 5 times 16 gives us 80 minus 4 gives us 76 degrees. So this angle right here is 76 degrees. Now we want to find y. All right, and we can go back and plug it into here if we need it as well. All right, so if we go back and plug it into there, 7 times 16 minus 8, 7 times 16 gives us 112, minus 8 gives us 104. All right, so this angle right here is 104 degrees. All right, and as it should be, that means we did it right, because if this is 76, 180 minus 76 gives us 104. All right, now if this is 104, it's vertical angles with this angle. All right, so we know that this angle equals 104. We can set up an equation saying 9y plus 5 equals 104. Another way you can do it is we know that this angle and this angle are a linear pair because they form a straight line. So we could say 76 plus 9y plus 5 equals 180. Both would be correct ways of solving, and both would give us the same answer. All right? So I'm just going to do it using the vertical angles way. So I'm going to say that 9y plus 5 equals 104 because they're vertical angles, so they are congruent. All right? Give me a little more space here to solve. Subtract 5 from both sides. Let's cancel out. 9y equals 99. Divide by 9. Y equals 11. All right? Now the problem's asking you to find the values of x and y, which you did. X is 16, y is 11, so you're done. All right, I want you to try to do number 15 on your own. All right, so P and Q are supplementary angles. What does it mean if two angles are supplementary? If they give you the measure of angle P and the measure of angle Q, first solve for x and then go back and make sure you find the measure of angle Q. So go ahead and try this on your own. When you come back, I'll have the answer written on your screen and we'll go through it together. So go ahead and pause your video now. Alright, so you should have gotten that the measure of angle Q is 123 degrees. How you got that? You know that P and Q are supplementary, meaning they add up to 180 degrees. We know P is 4x plus 1, so 4x plus 1 plus Q, which is 9x minus 3, equals 180. Combine like terms, move the 2 to the other side, divide by 13, and x equals 14. But you're not done once you solve for x because the problem's asking you to find the measure of angle Q. So we have to go back and plug it into 9x minus 3. When we plug it into 9x minus 3, we get that the measure of angle Q is 123 degrees. All right, if you have any questions, please raise your hand, call me over so I can help you, or turn to a neighbor and ask for help. Otherwise, let's move on. All right, number 17, a little bit of a trickier of a wordy problem, all right, but do not be intimidated by it. Read it one step at a time, represent it with mathematical equations and symbols, and then solve for the missing variable. All right, so J and K are complementary angles. We know that that means when we add them together, it equals 90 degrees. The measure of angle J, so we know that the measure of angle J is 18 less than the measure of angle K, so that means angle K minus 18. All right, and actually I should have put a little, got to put an M there, my bad. We want to always say the measure of angle K minus 18. All right, so angle J is the measure of angle K minus 18. Find the measure of each angle. Now we know that the measure of angle J plus the measure of angle K equals 90 degrees because they're complementary angles. All right. We also know that the measure of angle J equals the measure of angle K minus 18. So what we want to do is substitute this value in for the measure of angle J because that's what the measure of angle J equals. So we substitute this in. We say the measure of angle K minus 18, because that's what the measure of angle J equals, plus the measure of angle K equals 90 degrees. Now we combine like terms. So just like if this were x plus x, all right, would give us 2x. So we say 2 times the measure of angle K minus 18 equals 90. All right, let me move this up so got a little more space. Oh, it's acting funny. Sorry, guys. Now, we're solving for the measure of angle K, so add 18 to both sides. 2 times the measure of angle K equals 108. Now we want to divide by 2. Divide by 2. So 108 divided by 2 is going to give us 54. So the measure of angle K equals 54 degrees. Now you found the measure of angle K, but we need to find the measure of angle J. How we do that is, in order to find the measure of angle J, we know it equals the measure of angle K minus 18. So we take the measure of angle K, which we know is 54. 54 minus 18 is going to give us 36. So the measure of angle J equals 36 degrees, because it's the measure of angle K, which we found to be 54, minus 18. And you're done. All right, the last example we're going to do together today is number 19. And I apologize for these video notes being a little long, but there's lots we had to go over today. All right, so if ray MO bisects angle PMN. So angle PMN is this one right here. Oops. PMN. And MO bisects that angle. So that means it cuts it in half. So that means this angle is congruent to this angle. And we know that PMN is 74. So PMN is the whole thing. So if the whole thing is 74 degrees, if it cuts it in half, that means if the whole thing is 74 degrees, that each one equals 37, all right? Because 74 divided by 2 gives us 37. So 37 and 37. Now we know that OMN, which is this little one right here, equals 2x plus 7. We want to find the value of x. We also know that OMN equals 37 degrees. So we can say that 2x plus 7 equals 37. Solve for x, we would just subtract 7, divide by 2, x equals 15. And you're done, because it's asking you to find the value of x. Alright, so the important thing to remember here is that an angle bisector cuts the angle in half. Alright, so I hope you guys learned a thing or two about angle relationships today. If you have any questions, please call me over so I can help you, or ask a friend for some help. Otherwise, look to the board to see what to do next, and I hope that you have a great day. Bye!